If you haven't downloaded the Microcap 10 program, look at Diode Decimal to Binary Decoder Tutorial 1 for instructions. Tutorial 9 is a divide-down circuit. Each 7474 TTL-D flip-flop is wired to change state on the rising edge of its clock input. It means the Q output of each flip-flop is 1/2 the input count clock rate. Let's go to transient analysis. We set the time range to 10 microseconds. Notice the D before the node number. It means we are looking for a digital output. In this case, the X range and Y range can be set to auto. Let's run the analysis. Graph 1 shows the input clock and the Q output of the first flip-flop. Nodes 10, 12, 14, and 16 are the Q outputs of the next 4 flip-flops, shown on the next 4 graphs. If we run the transient analysis again, we see that auto has picked values for the X range. See over here, these values are what the auto picked for the graphs. We've gone back to this circuit. You should print a copy to refer to when you build this circuit. Your node numbers, which are shown in red, might be different, so you'll have to be careful about that. Now let's build this circuit. We get rid of the tip of the day. We come up to components, down to the digital library, over to the 7474 series, and we'll pick the 7474. However, before that, we want to put in a grid. We'll go to View, we'll go to Grid Fold, and we'll start putting these in. We'll put this flip-flop here, there, 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 and there. That's our 5 flip-flops. Now we'll start doing some wiring. Hold and release. Hold. Release, hold, release. I did some of the others so that you wouldn't have to wait for me. This is how we couple the first flip-flop to the second to the third, and so on. And now we're going to wire up the set and reset size of these flip-flops to prevent them from being locked. I'll take this to here, all the way over to here. Now we'll have to go and get a inverter. We'll set that there. We'll escape from there. Now we have to get a clock. So we'll go to Digital Primitives. We'll come over here and and come down to stimulus generators, and we'll pick the D clock. We'll come, and that's going to be our input source. Now this is set up at 50 nanoseconds and 50 nanoseconds, which is a 1 megahertz signal, but we're going to change that. We're going to make this 100 N. Make the other at 100 N also. And then we'll accept that. We'll get out of that. We'll wire that in. We'll wire this in. Bring that down. I'll escape from that. I'll get a ground. Bring the ground in. Our circuit is together, and so now we're ready to go to transient analysis. One of the things we want to do, though, is we want to see what the node numbers are. And notice these now are 4, 6, 8, 10, and 12. So it's 4, 6, 8, 10, and 12, and the clock is 1. We go to transient analysis. We're going to set this up We're going to set this up to be 10 microseconds for our range. We're going to, on these first two, put in the clock, which is D instead of V, 1. And we're also at this point going to put in the first output, which is 4. That's also going to be D. And now we're going to look at the other 4, so we have to add 3 more points. This is going to be graph 2, 3, 4, 5. Put the T in. And this has got to be D6. 8, 10, and D12. We're going to leave auto in all of these. And now we'll get rid of the operating point, uncheck that, and we'll run. And there we see we have the clock, the first flip-flop, the second flip-flop, the third, the fourth, and the fifth. So that's a way to set up 7474 dual D flip-flops for dividing the frequency of the clock input. That's the circuit. These are the nodes that turned out for that. When you wire it up, they may be a little different, so you'll have to be careful to double check that when you put the coefficients in the transient analysis window.